Fast, local inference is useless if tool calls misfire and JSON breaks in production. I'll use SGLang to run local agents that call tools and return structured outputs you can trust. This is the workflow you'll know how to run when we're done, which selects tools for a request and executes them to return a safe JSON result. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Tool calling and structured outputs solve a practical problem. You can run a model locally and still need it to call functions reliably. You want the model to choose a tool, pass exact arguments, and return predictable JSON your code can parse. Without guardrails, you get free text, broken JSON, and flaky integrations at runtime. With the right pattern, you get deterministic tool selection, validated arguments, and a final JSON object you can plug into databases or APIs. At a high level, SGLang tool calling turns the model into an orchestrator. The model decides which tool to call. The runtime captures that decision and runs a local function. Structured outputs force the model to reply with valid JSON that follows a schema. Together, they reduce parsing errors and external I/O that slows or fails in production. We will build a small, self-contained example that runs locally. It will discover a running SGLang backend, ask for strict JSON, let the model call a price lookup tool, enforce valid arguments, and then return a validated quote object. You will see how the system locks down the flow so human prompts cannot derail automation. First, we'll check the server and list models. This snippet connects to a locally running SGLang server and verifies it is serving at least one model. It creates an OpenAI client pointed to the SGLang OpenAI-compatible base URL and authenticates with a dummy key. The call client.models.list fetches available models from the server. The list is sorted into IDs to produce stable ordering, and the first ID is stored in model for reuse in later steps. Finally, the script prints how many models were discovered, confirming a live connection and a usable catalog. The printed count shows your SGLang backend is reachable and ready for workloads. Next, we'll ask the model to return a tiny JSON object and parse it here. This example requests a JSON-only reply from SGLang and parses it safely. The call client.chat.completions.create targets the model selected earlier and sends a short instruction asking for a tiny JSON object. The response format parameter is set to a JSON object mode, so the server guides the model to output valid JSON. With temperature at 0, the model response is stable and deterministic for debugging. The content string is parsed with JSON.loads into the variable obs, and the code prints the sorted keys to verify structure. The printed keys confirm you received machine parsable JSON suitable for downstream code. Now, we'll demonstrate tool calling and running a local function. This code demonstrates SGLang tool calling and local execution. The dictionary prices holds deterministic price data, and tools declares a single function tool named getPrice with a minimal JSON schema for SKU. A chat.completions.create call asks for a price, and SGLang returns tool calls in the assistant message when it decides the tool is relevant. The variable TC captures the first tool call. Then JSON.loads parses the arguments, so the local code can look up the price. Finally, the script prints the chosen tool and the computed price, confirming that tool selection and argument parsing worked end-to-end. The printed pair shows which tool was triggered and its result. Then, we'll add guardrails to restrict what the model can pass to the tool. This snippet tightens reliability by guiding both the model and the arguments. The code constrains the tool schema by adding an enum to the SKU property, so only known products are considered valid. The chat.completions.create call sets tool choice to getPrice, ensuring SGLang routes the request to the intended function rather than deciding freely. The seed parameter and temperature 0 improve reproducibility across runs, aiding incident-style debugging. The response's tool calls are parsed, and the chosen SKU is extracted for verification. The printed value confirms the enforced tool and argument choice, demonstrating guardrails that prevent off-spec calls. Finally, we'll close the loop and return a validated JSON quote. This example completes a compact agent loop that returns validated JSON. First, chat.completions.createWithTools asks for a quote, and SGLang replies with a tool call in tool calls. The code parses the SKU from TC and looks up price locally to avoid flaky external I/O. It then assembles messages that include the assistant tool call and a tool role message containing the price, giving the model the data it needs. A second chat, completions.create, uses response format with a JSON schema named quote and strict enabled, so the reply matches the schema. The printed total shows a structured, automation-ready result. This toy flow maps to a real product system easily. Swap the small prices map for a product database or a search index. Replace local lookup with a guarded API call behind retries and caching. The same pattern protects you. Model suggests a tool. Runtime executes deterministically, and the final response is schema validated. Quick recap. What it is: a pattern that combines SGLang tool calling with strict JSON output, so models trigger local functions and return parseable results. When to use it: any automation where an LLM must call services or functions, and you need predictable, machine-readable outputs. One caveat: you still must design tight schemas and validate every step, because the model can suggest unexpected flows if you leave too many open choices. Next step: scale this exact pipeline to a larger catalog and add timing and accuracy checks so you can measure latency and correctness at production scale. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.